Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Thank you. It's really a pleasure to be here today and an honor to have a chance to talk to all of you. What I wanted to do was to build on the lecture that you heard this morning from Rick Rashid on why Microsoft is engaged in research and the nature of research. And so let me just dive right in with a classic problem in computer science research, which is called the pancake flipping problem. And so I don't know how many of you are familiar with this, but I'll explain it. By the way, I do realize that there are different kinds of pancakes in India, so let me switch the picture to this. This will be a little bit better. So the pancake flipping problem is a very old classic problem in computer science. So we imagine that each pancake has a number, 1 through n, and they're all scrambled in this stack. And so now we want to sort the pancakes so that they are in order, 1, 2, 3, 4, 5, and so on to n. And the only operation that we are allowed is to insert a spatula somewhere in the middle of the stack and then do a flip of the pancakes that we pick up. And so the question is, for a stack of n pancakes, what is the minimum number of flips required in order to sort all of the pancakes? And there's a slightly harder version. In fact, there are many variations of the problem. A slightly harder and common variation of the problem is to imagine that the pancakes are actually burned on the bottom. And so you not only want to sort them, but you want to have the stack of pancakes end up with the burned side still facing down so that no one can see that the pancakes are burned. So this is a very old problem. And one of the surprising things about this problem is that one of the most important early works on this problem was done by the founder of Microsoft, Bill Gates. And this is way back in 1979 when Microsoft was still a very, very small company, not even in Redmond, Washington. And so the reason to explain this is to just give you a sense of how much research means to Microsoft. It's really, in a sense, in the DNA of Microsoft, really going back to its founding, where even the founder of Microsoft, co-founder of Microsoft, was directly involved in research and publishing in research journals. So now, continuing on the theme of working on problems, what I'd like to do now is to give all of you a test. And so if you will bear with me. On the next slide, I'm going to show you a picture. And the picture will have lots of different colored and sizes of dots. And so what I will do is ask you to look at this picture carefully and tell me how many red dots there are. And I'll give you 5 seconds to complete the test. Okay? All right, here we go. 5, 4, 3, 2, 1. How many blue dots? I can hear many of you talking, but I don't think I heard the right answer. There are actually 7 blue dots, but here's the actual point of the test. When we work in Microsoft Research, and for anyone in research, when we try to work with the product groups, the teams of people who are very hard at work and very focused developing new products, those product groups are exceptionally disciplined and focused. They're trying to understand deeply what does the customer need, what does the customer want, what problems does the customer have that we want to solve, and when do we need to finish our product in order to make sure that we can satisfy the customer's needs. And so there's a level of focus and discipline. And all of you in this room, when you were counting the red dots, you were also showing the same kind of focus and discipline to solve the problem. And that is very similar, analogous to the focus that product teams have. But every once in a while, it becomes important to know other things. In this case, to know how many blue dots there are. And so one of the roles of research, at least research in a company like Microsoft, is to have a body of people, a well of knowledge to draw on in case the unexpected happens and we need to know something new. Or we might even come to a realization that the world has changed and suddenly it's more important to know how many blue dots there are than red dots. And so in research, one of the things that we always try to do is look for the unexpected and try to understand not just the current focused product that we're trying to develop, but all of the things that could be needed in the future, all of the other things that our competitors might be thinking about working on, all of the ideas that are flowing in all of the researchers in the broader research community. And so this is, in some sense, for me, a way to think about our role in Microsoft. And for that reason, Microsoft Research and researchers in general are a different kind of people. Early this morning in the first session, there were several questions from you that basically was asking, can a programmer get involved in research? What does it take to get involved in research? And I think, in some sense, if you are the type of person that loves surprise, that loves solving problems, that doesn't need to be told what direction to go in, but you can set your own direction, then research is really for you. And that's something that, that I think you can all keep in mind. Now, let me give a more concrete technical example of this idea of surprises or seeking the unexpected. That really made a difference in both the basic research community and in Microsoft. And I was chuckling earlier today, in fact, throughout the day, because, in fact, the problem I want to talk about is the problem of hearing someone's voice in a room full of people that are all making a lot of noise. And so somehow this problem seemed perfectly appropriate for the day. So this is actually a picture here. It's a famous picture of the scene on the New York Stock Exchange floor. And here you can see lots of people shouting, and there's one person in the middle with a notebook taking orders for trades to sell or buy shares in various companies. And so the remarkable thing about this is that in this crowd, with all of these people shouting, and lots of noise and bells ringing, people running around the floor, in all of that pandemonium, it is still possible for a human being to focus his or her thinking on a person that they can see in the room and have a chance to hear it. There's a way that our brains are able to take the fact that if I'm trying to listen to you and everyone else is talking, I can process in the computer in my head the fact that when you speak, the time difference in the arrival of your voice to my left ear versus my right ear will be different in just a certain amount. And in my mind, I'm able to process that and focus my hearing on that person. This is an amazing thing that humans, in fact, many, many animals are able to do. And so one of the classic problems in signal processing and computer science is how, in fact, to build a machine that can do the same thing. And so if we want to build a machine that has a microphone, that's depicted in the middle of this diagram, and we're trying to have that microphone hear a specific person's voice. Of course, it's made more challenging by the fact that that person is in a noisy, crowded environment. And in fact, that environment might contain other sources of noise that surround the microphone. The question is, can we build a machine that can still pick out that person's voice? And this problem, of course, just as it does in humans and in animals, requires more than one microphone. And so we might have a microphone array. The idea being that if we're able to calculate or compute using a computer the time difference in when a person's voice that we're trying to hear hits each of the microphones and make some sense out of those time differences through what's called an audio pipeline, then we might be able to pick out that person's voice and get some other information, such as the direction that the voice is coming from. And so this is a classic problem in computer science, and we have a research group in our lab in Redmond, Washington, that works very hard on this and closely related problems. That group is led by a researcher named Ivan Tashev. Now, In fact, Ivan has been working on this problem. I think his first paper that he published was back in 1997. He was doing work in biomedical engineering and really trying to understand the computational processes in animals and humans. And then later, after 2000, around 2001, 2002, he ended up inventing something called the MVDR adaptive beamformer. And that MVDR adaptive beamformer actually set a standard for the kind of signal processing to do to solve this sensing problem. Now, that is an example of what I call blue sky research. Here we have a researcher who just has a curiosity. How is it that a human can pick out a person's voice in a noisy room? And also has the additional curiosity, can we make a machine or a computer do the same thing? And so that kind of very basic curiosity-driven blue sky research is an important style of research, and certainly a style of research that we support very strongly in Microsoft research. But for really good researchers, that's not enough. Once you think you've figured something out, you actually want to build it and try it out. And so in this case, this was true for Ivan Tashev. And so what I'm showing here actually is a machine that Ivan and some students that he worked with built. And if you look, this machine has 9 microphones in it. And so those 9 microphones then are going into a signal processor that's in a computer. And so if you put this microphone in a room with lots of noise and say, please listen to a noise at a certain point in the room, then it's able to calculate through the time difference of the sound travel to each of these 9 microphones and able to filter out all the ambient noise and just have crystal clarity on the person's voice. And so let me give you a demonstration of this. I'm going to play 2 audio files. The first one will be a recording of a microphone in a noisy room, just recording a person talking, but lots of other people talking and walking about. So I'll just play this. It's just an 8-second audio file, so listen carefully.
Xbox, shuffle. Take a deep breath.
Okay, so that's a very noisy room, and when you have a single microphone, this is something that is pretty typical. In fact, I would dare say that if we had a single microphone on this stage today, that we would hear some very, very similar kind of noise. So now, in the same room, recorded at exactly the same time in the same place, is this 9 microphone device placed, and now with the new adaptive beamforming. And listen carefully.
Xbox, shuffle. Xbox, dashboard. Xbox, go back.
And so now, suddenly, out of all of that noise, almost everything has been filtered out except for the single person's voice that we're trying to hear. And so very similar to the capability of a human. We have a machine now that's able to pick things out. All right, so this is what I would call an example not of blue sky research, but of inventive or disruptive research, trying to be the very first to build something that does something new. So what happens in Microsoft research then is that we show these things that we build to the product groups. And we have lots of ways to do that. One thing that we do within the company is a show called TechFest, where all the researchers show off their best inventions to the product teams in the hopes that the product team will have some interest in making use of it. And so, in fact, the product team took a look at this test rig and was very, very interested in using it. But, of course, this thing is not something that you would want in your home. This is just too big, too ugly, too expensive. And so they asked for some changes. They asked, for example, well, the microphones that are being used are too expensive. So can you please make it with cheaper microphones that don't work as well? Boy, that seems kind of hard. And then on top of that, they asked for more things. How about just using 4 microphones instead of 9? 9 will be too expensive and too complicated. Let's just have 4. Also, that test rig used push to talk. In other words, you would push a button so that the machine would know that you're talking, and then it would listen, and then you'd let go of the button. And so the product team said, no, let's not have push to talk. It should just be listening all the time and be able to hear anyone. And then the last thing is that it's important in this system for the microphones to know the shape of the room. And so in order to do that, what the device does is it emits a piercing noise that echoes all over on all of the walls, and then it tries to calculate through the echoes of that piercing noise throughout the 9 microphones essential parameters of the shape of the room. And so, of course, you don't want devices in people's homes emitting really awful shrieking noises. And so is it possible also to have a pleasing tone for calibration? And as simple as that sounds, all of these things are extremely difficult technical challenges. And in fact, technical challenges that one might at first blush think is not possible. But in fact, the whole thing was successful. And those of you who are familiar with the Kinect, and if you aren't, the Kinect is a beautiful device for an Xbox or for a Windows machine that is able to see in 3 dimensions, track a person's skeleton so that it can understand your physical positions. And it has a 4-microphone array that does adaptive beamforming, so that if you're watching, for example, a movie or television with your Xbox, you can actually, from sitting on your couch, just talk to your Xbox and say things like, Xbox, Bing, Clint Eastwood movies, and you will get a whole selection of those kinds of movies. And so what we moved then from is from blue sky research to disruptive research to mission-focused research, the mission to actually make a product that is cheap enough to manufacture and pleasant enough for people to want to buy. Now, all of that work is very interesting, but we are also scientists and scholars, and we participate in the open research world. And in that open research world, one of the most important things to do is to publish the results of our research. And so, in fact, in this case, Ivan Tashev and a student, Nilesh Madhur, and another colleague at Microsoft Research, Alex Cicero, wrote a paper on this adaptive beamforming and microphone array technology. And this is an image of that paper. And that publication, that open publication policy that we have at Microsoft Research is exceptionally important. It's a way for us to share the new knowledge that we develop and to participate and interact and also benefit from all of the great ideas and new research that people in universities do. Now, one interesting thing about this paper is that this paper was published a few months, about 10 months before, or submitted for publication about 10 months before the Kinect was launched for sale. And the thing that was sort of funny about this is that this paper was submitted but then rejected for publication. And maybe there's a lesson here that for those of you that do end up trying to get into research, another aspect of life as a researcher is that you get rejections all the time. So I was rejected by the first 3 graduate schools I applied to. A large number of research papers that I've submitted for publication have been rejected. A large number of grant applications that I've submitted have been rejected for funding. And in here we see a paper that was also rejected. And if you get a rejected paper, you get comments from reviewers who have carefully reviewed your paper. And the comments on this paper were pretty deadly. One reviewer said, "The solution proposed obviously doesn't solve the problem at all." Someone said this makes no improvement to the state of the art. The last one, reviewer said that this approach has serious drawbacks for realistic scenarios. And of course, the reviewers in this case were all wrong, because in fact, this paper, the ideas in this paper were going into a product that has been the fastest selling consumer electronics device of all time. But what happens here is that sometimes when you really push the frontiers, it takes some time for reviewers to really accept that there are new ideas or new approaches. And so the story I told you is just a larger story of the red dots and blue dots. We start with just basic curiosity-driven research. We just wanted to understand how is it that humans can pick out a voice in a noisy room. Then we get to the point from there of trying to build something once we think we have some understanding. If it's useful in a company context, then we might fall over to the mission to actually build it into a real product. And then even once we have the product, our work isn't done because there are always ways to find new uses of the technology or to make improvements to the technology. And so this is what I refer to as the pipeline of blue sky research to surprising inventions. This idea that at every step we can surprise ourselves and keep the technology moving forward. And in fact, as a manager of several Microsoft research labs, I use this pipeline in a way of organizing the structure of our research investments by looking at all the possibilities in research and looking along the x-axis here at research that has a short time horizon, research where we want a quick answer versus research where we need patience. And then on the y-axis, the kinds of problems that we solve, problems that are known to us, that maybe people pose to us, and as we move up the y-axis, research problems that are just purely open-ended, curiosity-driven. And this set of 4 possibilities in this space of blue sky, disruptive, mission-focused, and sustaining research is, for me, a management principle on how we keep advancing the field. So that's Microsoft Research. What I wanted to do now is talk a little bit about all of you. And I'm hoping that some of you might someday develop a strong enough interest in that pipeline of research that you also might aspire to becoming a researcher and getting involved in research. And so let me say a little bit about this as I look to all of you. And I came here assuming that most of you were around 20 or 21 years old. And if that's true, then at least in the United States, people tend to work after they get out of college or graduate school, and then work a whole lifetime, and then there's a standard retirement age of 65. So if you're 21 years old, that means if you're in the US about 44 years from now, you have 44 years of work ahead of you, and then you would be ready for retirement. And so one question to ask when you think about research and you is, what is the world going to be like 44 years from now? And what will your role be in inventing the technologies and tools and ideas that exist in the world in 44 years? Because all of the speakers here today will be long gone before that happens. And it will really be in your hands to invent that future. And if you have an interest or an aspiration to create that future, then this is one reason to get into research. Now, looking ahead 44 years is really hard, very, very hard. And so one exercise I go through is, in order to try to imagine what life will be like 44 years from now, is try to look back 44 years and look at what happened 44 years ago. And so 44 years ago was 1969. And I was 9 years old, I remember. So you can figure out how old I am. And so in 1969, an amazing thing happened in science and technology. And that is, that was the first year that we put a man on the moon. And this is a very, very famous picture from National Geographic of the time, of a picture of Neil Armstrong on the moon. That's, for me, when I was a 9-year-old child, this made me want to become a scientist, made me want to become a researcher. Just the very idea that you could work with tens of thousands of other people for the single goal of putting a person on the moon was just completely inspirational. The other thing that happened 44 years ago, in the same year, 1969, is what is referred to by some computer scientists as the mother of all demos. Because in 1969, in computer science, something very important happened, which was the creation of the ARPANET. And the ARPANET is really the foundation of what we now see as the Internet. And so in 1969, there was first in July the stringing of 2 nodes, one in Palo Alto and one in Los Angeles, and then there were 2 additional nodes. And when there were the 4 nodes in December, Doug Engelbart gave a demo showing how a person in Utah and a person in California using that network could collaborate over a long distance on the creation of a document. And this was really a stunning achievement in science and technology. And this happened in the same year that we put a man on the moon. That's good. So I'm asking a very silly question here. And so don't take this too seriously, but I want to pose the question anyway, just to get you all to think. Of these 2 amazing events in 1969, these 2 amazing events 44 years ago, which one was more important? And it's a silly question because both were monumentally important, and it's really, there's no basis for picking one over the other. The other thing to think about is you think about these 2 events 44 years ago, what do you think will happen this year that people at your retirement age will look back on to be as important? Now, on this question of which one of these 2 had more impact, I have a silly answer to this silly question. And that silly answer is, will your child go to the moon? And so I have a son who is 15 years old, and he has never used Saturn V booster technology to help his homework assignments. He's never used lunar landing technology to find new videos and new entertainment or to socialize with his friends. But he has used the ARPANET technologies, now called the Internet, to do those things. And so the point here is that one of the things that's special about computing research is that the results of computing research oftentimes create technologies that become available to everyone. And when you have a technology that's available to everyone, that's called technology democratization, you always get new technology disruptions. Because by putting extremely powerful technologies in the hands of very large numbers of people, you have an engine for new inventions and new ideas that it just leads to everything that we've seen in the computing and information technology industries over the last 50 years. And so for this reason, I just think of computing research as the most important and most amazing place to be working. So as we get back to you, I now want to announce something to get all of you a chance to be involved in a research project with Microsoft Research. And I'm going to explain this research project by describing a project I ran back in 2009 called the DARPA Network Challenge. And so this was a research project that I had that was staged as a contest. And so in this contest, what we did is we had 10 8-foot wide red weather balloons, and they were held on 100-foot ropes and anchored to the ground, and they were hidden throughout the United States in the locations that you see on the map here. And they were then held aloft 100 feet in the air for 8 hours on the day that Doug Engelbart's famous mother of all demos took place. And what we did is we challenged the world to find these 10 balloons. And the idea being that the first person or team to find the correct location of all 10 balloons would win the first prize, which at that time was $40,000, really a lot of money. So what had to happen is, and the whole purpose of the research project, was to see if computing technology could be used to rapidly mobilize a large enough army of people so that you could have a chance of going out throughout the entire United States and finding these 10 balloons. Now, as it turned out, over 4,300 teams signed up for this challenge. And in fact, those teams managed to recruit millions of people, not just in the United States, but all over the world. In fact, there were hundreds of people from India that participated as members of teams in this contest. The amazing thing is, in that contest, out of 4,300 teams, a team from MIT managed in just 48 hours to mobilize about 2.5 million people and used those 2.5 million people to find all 10 balloons in less than 9 hours. Really an amazing accomplishment, and it shows the power of social networks. Now, this contest of finding red balloons is a little bit silly because it's not very useful. But imagine if there is a disaster and we need to find and mobilize an army of people who can operate heavy machinery, who can tend to people who are injured. What if people are lost and displaced and we need to mobilize an army very quickly to help find lost children? The possibilities in being able to mobilize large numbers of people to do things could be an extremely powerful use of computing technology. And so in Microsoft Research India, in our India lab, we have research going on that's very interested in understanding the possibilities of computing technology to do that. And so what I'd like to do is describe that project and invite all of you to participate. And so before I do that, let me first describe how did the MIT team win. And so here's what they did. They opened their doors, they had a website, and it said, sign up and work for us to find balloons. So if you signed up to work for MIT, and then you went out in the world, and you were the first person to find a balloon for MIT, then they would pay you $2,000. But that's not all. If you, on top of that, signed up for MIT, but also recruited a friend to also work for MIT, and your friend found the balloon, then your friend would get $2,000, and you would get $1,000. And that was an important incentive because that meant that you had an incentive not only to hunt for red balloons, but to recruit as many of your friends and family members as you could possibly find to also help you find balloons. Because if any of them found a balloon, you would win $1,000. Furthermore, if you recruit someone who recruits someone who finds a balloon, then you will win $500, and so on. And so it kept going down by halves. And so using this so-called recursive incentive structure, or lottery tree, the MIT team was able to very quickly motivate people not only to go hunting for red balloons, but to recruit as many people who might themselves recruit as many people who themselves might recruit as many people to find red balloons. And this turned out to be a very effective way to do things. And this is only one way that you might accomplish this task of finding these balloons. There are many, many others. So now, let me get to Microsoft Research and the project in the India lab and ask you to participate in an experiment with us. And I hope you all will participate. And this is really a question, research question. Is it possible for you, for each of you, to mobilize 1 million people? Perhaps you would use the internet. Perhaps you would use text messaging on your phone. Perhaps you would just use a telephone and call your friends. How would you do it? And so to do this, we're launching today a contest called the Who Done It Challenge. Actually, it's not today. It's starting February 1st, next week. And on that day, the first person who can mobilize a large number of people in India will win 1 lakh rupees. And so now let me give you the rules and how the contest works. We have a server set up, and in that server are hidden 5 secret clues. The clues tell something about who, about what, about where, about when, and about why. And all 5 clues together tell a short story. So for example, the server clue for who might be my name, Peter Lee. It isn't, but it could possibly, just as an example. The what might be that I visited someplace. The where might be that I visited here in Coimbatore, that I did so today, and I did this visit today for the Tech Vista conference. And so the contest is to try to find all 5 clues and piece them together. And the way that you can get clues is as follows. You can use your phone and send a message. First of all, send us a missed call. And then, from that, you will receive a clue back by SMS. And then to win, all you need to do is do that enough times to get all 5 clues, and then submit all 5 clues by SMS. And if you're the first person to do that, you will win the 1 lakh rupees. Now, there's a catch, because if that were the whole contest, it would be a little bit too easy. There's only 1 clue that will be given per phone number. So that means you need at least 5 different phone numbers to have any chance at all of getting all 5 clues. But more than that, some clues are much more common than others. And so, in fact, by probabilities, you will need to have a very large number of people working as a team in order to have a chance to get all of the clues. Okay? So the contest will start on February 1st, and so you have between now and February 1st to get involved and to mobilize your team. And so the contest will run February 1st to February 15th on 2013. This is the phone number. You can get more information about the rules and how it works on whodunitchallenge.com. Please start building your team now. We'll be learning a lot about mass mobilization through networks for our research projects, and you'll help us advance the field. So thank you very much.